All right, we are ready to get started with the Pathfinding AI video series. Now, of course, this series is continuing the project that was built in the first video set. Of course, in that video set, we put together a behavior demo, and if I launch this briefly, we can see we set up a scenario where we have various behaviors layered together to give a motion result. So we have a leader object with some follower objects to put together a simple scene. Now, as we continue our journey into AI design, we're going to be moving into more advanced topics like pathfinding, but we're going to be beginning with this project as a base. Now, in order to be able to build onto this project, I'd like to be able to maintain the scenes that we have created so far while being able to move into and create new scenes. I'd like to keep this all managed inside of one project rather than splitting it up into different separate solution files. So what we're going to do is we're going to set up some simple scene management that will let us move a lot of the code we've created so far. For example, if I scroll down here to the load content section, you can see that we've got a lot of code in here that's putting together our scene. What we're going to do is we're going to create the idea of a scene class that's going to contain the code necessary to create, update, and draw any given scene. This way we can maintain our old scene and begin a brand new scene in order to progress through the pathfinding video lessons. So to get started, let's create the actual scene class. Up here inside of our behavior demo project, I'm going to right click on it and we will add a new class. And this class is going to be called Scene. So we'll give it a second to load up our new Scene class. The very first thing that we'll need in the Scene class is a few using statements. So we'll drop in a using for Microsoft.xna.framework. And we will also add framework.graphics and framework.content. Alright, now that we've got the necessary namespaces opened, let's move into the scene class itself. The base scene class is simply going to contain empty virtual methods that will be used as the foundation to build individual scenes. So it's simply going to have placeholder methods that are meant to be overridden by a specific scene. So, a brief overview, we're going to have three methods: build scene, update, and draw. So let's put together the method signatures for these methods. We'll begin with a public virtual void method called build scene. And build scene is going to take in a few parameters to aid in the construction of the scene. It's going to take in the graphics device so that if we need to create textures or find the size of the screen, we'll be able to look into the graphics device. And we're also going to take in the content manager in case we would like to use the content manager to load assets like textures. So for a first parameter, we'll make a parameter of type graphics device, and we will call it graphics device. For a second parameter, we will make a parameter of type content manager, and we'll call this parameter content. Now we can drop in some braces for the method. In this case, I'm actually going to move the braces to just beside the method signature itself, since we're not going to be doing any implementation in this class. So we'll keep everything very close and tight together. Alright, moving on from build scene, the next method we're going to address is the update method. This is going to be a public virtual void method, of course called update, and just in case it's needed, we will pass in the game time that an XNA game's own update method would have. So this will be a game time parameter, and we'll simply call it game time. And once again, we will put an empty method body out to the side of the method definition. Alright, one final method. This is going to be public virtual void, and the method name will be draw. Into draw, we will take two things: a graphics device and a sprite batch. So we'll pass in a graphics device. Again, we can call this parameter graphics device. And for the second parameter, we'll be taking in a sprite batch, and we'll call this parameter sprite batch. And once again, we will put an empty method body out to the side of the method definition. So with this simple class in place, this will make the base class for scene. So if we would like, we could build briefly, just in the habit of keeping everything saved as we progress. Now we can move on to a specific scene that will hold our current demonstration. What we'll do is we'll make a scene called behavior test, and we'll place the current scene that currently exists inside of load content. So to put this in action, we'll create a new class. So up here in our project, we will add a class, and we will call this class scene behavior test. Then the first thing we'll do in our new scene behavior test class is we will make sure that it extends scene. Now, as we're putting together all of the elements of our scene, we of course need access to the various types in X and A. So to get our using statements set up, what I'll do is I'll simply jump over to scene and copy all of the using statements. And this will quickly get namespaces open for framework, graphics, and content. Now, inside of the behavior test scene, in addition to the code that will be placed in the various methods, we'll also need some fields put in place. Currently, if we look at our game and we scroll up to the very top, we're relying on these two fields of screen width and screen height in order to describe the size of a screen. Now we're going to be changing this slightly to get the size from the graphics device, but rather than going through line by line and adjusting our code to use the graphics device instead of using these fields, we'll simply move the fields over into the behavior scene and update them in one place instead of changing them throughout. So what I'll do is we can simply take both of these fields and cut them to move them out of the game and jump over to our behavior test and add them into the scene behavior test class. Alright, now we're ready to begin migrating the code from the game into the scene. So we'll begin at load content and bring all of the code that builds the scene into the scene behavior test class. Of course, we're going to be doing that inside of the build scene method that we get from the scene class. So we will begin by overriding the build scene method. I'm going to take out the call to base.buildScene, of course, because we left that blank in the base definition. Now, before we actually move the code over, again, we have these dependencies on these two fields, screen width and height. So we're going to make sure that those get initialized properly based on the graphics device. Rather than hard coding in these values, it would be nice if these follow along, since we've kind of broken our link now, where in the game we were originally setting the preferred back buffer width and height. We'll have to adjust these lines, of course, since they're relying on those fields. But rather than maintain a reference to fields, we'll use the graphics device itself. And this will be done through the use of the presentation parameters presented by the graphics device. Inside of build scene, we will actually drop in a local variable of type presentation parameters, and we'll set this variable, pp, to be equal to the current graphics device being passed in as the parameter, dot presentation parameters. Now we can turn around and use our more conveniently named local variable to set up screen width and height. So we'll start with screen width, and we'll set that to be equal to pp dot back buffer width, and screen height to be equal to pp dot back buffer height. And that takes care of initializing screen width and height. I'm also going to jump up and remove our field initializers for screen width and height, because they will instead be initialized by the build scene method. Alright, now that we've got our field set up, we're ready to copy the code from load content over to build scene. So inside of game 1, we're going to scroll down to load content. We're going to begin at this arrow texture 2D variable, and we're going to begin selecting code. Now, of course, this goes far below the current viewable area on the screen, so I'm going to continue selecting lines of code until we get to the very end of the actual scene creation. So just slowly looking through the stuff we're creating. We're down here at the bottom now where we're creating drones. And finally, we're assigning the obstacles to be avoided by the leader actor. So stopping here, we're right before the ending brace of the load content method. So with all of this code selected, I'm going to cut the selection, then move into the scene behavior test class, and paste this code into build scene right below our screen width and height. So having pasted all of this in, let's scroll back up and see how everything is looking as far as fields are concerned. Screen width and height seem to have copied over just fine. When we're using the content manager to load the arrow texture, we're looking for a field using a capital content. We're passing this in as a parameter with a lowercase content, so we'll make a small adjustment there and look at the proper content manager. So just very quickly, I'm going to glance through this code looking for any underlined code that might indicate syntax errors, and I'm not seeing any, so that seems to have pulled over just fine. Now, if we look back at the game class briefly, we can see that up here at the top of the constructor, we're still relying on screen width and height, which all along we were using 800 by 600. So I'm not going to worry about actually setting that here. If we had wanted an alternate screen resolution, we could now set these with specific values. For example, 1024 by 768, and because that ends up getting stored in the graphics device, we can pull that back out over here through the presentation parameters. We don't have to worry about the fields anymore. So I'm going to jump up here and take out both of these lines, since again, for our scene, we're just using the standard 800 by 600. Alright, now one last tweak I want to do to those fields. Since they are being used here as private fields, I'm going to change the casing on both of these to reflect the fact that they are indeed private. So now that everything has been moved over and we're using the correct fields inside of the scene, I'm simply going to hit F2 to use refactoring and rename them. So capital screen width will become lowercase screen width, and then apply throughout all of the code using them. And we'll do the same thing to screen height. It will become lowercase screen height, and that takes care of our field names. Alright, now let's jump over to our update method. So we need to move the code from the game class. We can very briefly jump over to this code. Scrolling down here inside of the game, we have this actor update loop and also the code that applies our screen warp behavior. So what we're going to do is we'll go into our scene behavior test class. We'll jump in here right below the build scene method, and we will override the update method. And again, we will pull out the call to base.update. Now, we'll take the code that's currently inside of our game's update, which here is just going to be this for each loop, looping through actors. We'll cut that and move it over to our scene. So we'll paste that to put it in place, and we have the fields looking at screen width and height. Very quickly I'll go in here and rename them. Since we have already refactored them, they're now looking at new names of lowercase screen width and height. Alright, but with this block of code we now have the update code moved over into our scene, and we have one last method to address, which is draw. So I'll jump in here below our update method, and I'll add our final override to gain access to the draw method. Once again, we'll pull out the call to base.draw, and we will obtain the code currently inside of the game class. So scrolling down here to game, we will grab everything except the call to base.update. We're actually going to grab the call that includes clearing our graphics device and issuing the sprite batch begin and end. This will let us set different background colors to our different scenes. So we'll cut to move all of this code out to our scene. We'll jump in here and paste this inside of the draw method. And then one thing we need to change is the field graphics device is now indicated by the lowercase parameter. So we'll simply change the casing on graphics device, and that will take care of our field. And briefly looking at the error that has loaded up, it's not liking something about the name used. And it looks like that's because of a spelling error in the actual method definition. To correct this, I'm going to very briefly, inside of this class, simply hit F2 over graphics device, over the parameter, and simply change the name on device. And then refactoring should take care of updating that back in our scene definition, and that clears up graphics device here. We could briefly verify that inside of scene to make sure we don't have this problem in the future, and it looks like, well, due to the nature of that being a parameter, we're still using the wrong spelling here, so I'm actually going to correct that here in both cases. Again, just going through the effort of correcting this in scene to make sure that next time we make a scene and override these methods, we pick up the correct names. Alright, so with the correction in place, we now have the code inside of Draw, all of it looking good. So the last thing we need to do is go into Game and make sure that Game issues the proper calls to the current scene. So here inside of Game, we have already taken care of screen width and height. So now we need to have a scene field so that the game knows what scene it's updating. So we'll make a scene private field, which we'll simply call scene. And we won't worry about initializing it just yet. We'll leave it null here as in the field definition. Now where we're going to create it is down inside of the load content method. Since again this is going to mimic the same behavior as before, we're going to create the scene. Technically we're still going to create it from load content, only in this scenario we're going to be creating it via a call to the scene's build scene method. So here inside of load content, we first need to instantiate the scene so that we can use it. So we're going to take our scene field and set that to be equal to a new instance of scene. Then we will immediately turn around and use that scene. Actually, let me go back a step. With the scene itself, we want this to be of a specific type of scene. We have all of our scene existing in scene behavior test, so we need to set this to scene behavior test. Again, storing the field as a very general high-level field so that we can set the scene to other types of scenes as we create them. Now, with our new scene in place, we will first call its build scene method. And into build scene, we need to pass the graphics device and content manager. So we'll pass in the field from the game graphics device and the field content. So that should take care of our scene. Now, of course, all of that code is now encapsulated in the scene itself, so that greatly reduces the amount of code here inside of load content. Now we can move down to the update method, as we need to make sure our scene gets update calls. So we will look at our scene field, and we will call update on scene, where we will pass in our current game time. Now, one final thing we need to do is here inside of draw, we need to make our call to scene.draw, passing in the current graphics device and the current sprite batch. Alright, with all of this code in place, looking at everything that has been moved over from game to scene, we should be able to build and run the game, and everything should appear exactly as it did before. So a quick build, we'll hit F6, and then we'll hit F5 to run the game. And here we have exactly the same result. We have our main set of actors all built together comprising the scene, and everything seems to be behaving appropriately. So with that now, we have begun our journey into the Pathfinding series of videos by putting together scene management, because of course at this point we are now free to define new and different kinds of scenes and switch between them easily by simply maintaining any one instance of them at a time from our game class. So with that, that's going to wrap up this video.